Hi class, good day! This time, we are going to discuss about solving the sum and product of the roots of quadratic equations. There are other interesting and useful relations between the coefficients and roots of quadratic equations. It is possible to determine the sum and product of the roots without solving a quadratic equation. All we need to do is to consider the numerical coefficients of the quadratic equation. By using the quadratic formula, the roots of a quadratic equations are r sub 1 equals negative b plus the square root of b squared minus 4ac over 2a, and r sub 2 equals negative b minus the square root of b squared minus 4ac over 2a. Now let's have the derivation of the formula of the sum of the roots. Now, let's have the derivation of the formula for the product of the roots. Now we can summarize the formula for the sum and product of the roots of a quadratic equation. If r sub 1 and r sub 2 are the roots of the equation ax squared plus bx plus c equals 0, then sum of the roots is r sub 1 plus r sub 2 equals negative b over a. Product of the roots is r sub 1 times r sub 2 equals c over a. Now let's have our first example. (2x squared plus 5x plus 7 equals 0), and it is already written in the standard form. So let's determine directly the values of a, b, and c. So a equals 2, b equals 5, and c equals 7. Now let's solve for the sum and the product. First we have the sum of the roots. So sum of the roots, we have negative b over a. So it's negative 5 over 2. For the product of the roots, we have c over a. Then substitute the values, so we have 7 over 2. So the sum of roots is negative 5 over 2 and the product of roots is 7 over 2. We have 9x squared equals negative 3x plus 5, so we're gonna transform this one into the standard form. So copy 9x squared, transpose negative 3x, it will become positive 3x, positive 5 will become negative 5, then equals 0. Then let's determine the values of a, b, and c. A equals 9, b is 3, and c is negative 5. Now it's time to solve for the sum of the roots. We have negative b over a, then substitute the values. We have negative 3 over 9. We can reduce it. Both are divisible by 3. So we have negative 1 over 3. Now for the product of roots, we have c over a, then substitute the values. We have c is negative 5 over a, which is 9. So the sum of roots is negative 1 over 3 and the product of roots is negative 5 over 9. The relationship between the roots is useful in writing the quadratic equation whose roots are given. Example: here we have the pattern in writing quadratic equations. X squared minus sum of roots times x plus product of roots equals 0. So we have 9 and 0, so 9 is r sub 1 and 0 is r sub 2. Now let's get the sum and the product of the given roots. Now to look for the sum, just simply add the two given roots, r sub 1 plus r sub 2. So it is 9 plus 0. 9 plus 0 equals 9. Now, let's solve for the product of the roots. So just simply multiply the given roots. R sub 1 times R sub 2. So basically it's 9 times 0. 9 times 0 is 0. Now, we are going to substitute the sum and product to the given patterns. So we have x squared, then we have 9, which is the sum, times x plus 0, which is the product of roots equals 0. Simplify. X squared minus 9 times x is 9x plus 0 equals 0. Or we have x squared minus 9x equals 0. So, the equation is x squared minus 9x equals 0. Another example. We have 1 and negative 10. 1 is r sub 1 and negative 10 is r sub 2. Now the same process. To get the sum, just simply add the given roots. So we have r sub 1 plus r sub 2. 1 plus negative 10. So they have different sign. The answer is 1 minus 10 is negative 9. Now for the product, we are just going to multiply the given roots. We have r sub 1 times r sub 2. So we have 1 times negative 10. 1 times negative 10 is negative 10. So the product of roots is negative 10. Now it's time to substitute the sum and product to the given pattern. So we have x squared minus negative 9 times x plus negative 10 equals 0. Simplify. We have x squared. Negative times negative is positive. So plus 9x. Then positive times negative is negative. So negative 10. That's all for today, class. Thank you and God bless. Bye!